All right, IM2 classes. Today we're talking about properties of parallelograms. Um, so in class, we'll be answering this question about what are some properties of parallelograms that you think, because if you look at a parallelogram, things are going to be pretty obvious. By definition, a parallelogram is a quadrilateral, so it has to have four sides, and opposite sides have to be parallel. But because the opposite sides are parallel, as a consequence of that, we get some interesting properties in here. So first two properties that we're going to talk about. So not only are opposite sides parallel, opposite sides are also congruent. So remember these tick marks here. Those notate that when side lengths are the same size. So QR is equal to PS and QP is equal to RS. So opposite sides are the same. And then opposite angles. So angles across from each other. So we denote that by these arcs. So angle Q and angle S have the same measure, and then angle P and angle R have the same measure. Since these have two arcs, right? They're not the same here. So let's get an example of how to use this. So we're going to find the values of X and Y. That got cut off. That's a 2 right there. And yeah, let's not. So find the value of X and Y. So what we know here is that AB is equal to DC. So that means X plus 4 is equal to 12. And then we need to just solve for X. That's a simple one. Probably do that in your head. Subtract 4 from both sides. So plus 4 minus 4 cancels out. You get X is equal to 8. Now we need to set up the same thing with the Y. So here, the opposite angles are the same measure. Nothing to solve on that one. So Y is equal to 65. Super easy. Done. All right. Next two properties that we're going to talk about is the angles that are together. So if in a parallelogram, if the angles aren't equal, they are supplementary. So any X plus a Y is equal to 180. Remember, that's what supplementary means. It means adds to 180. So anytime you have angles that in a parallelogram, if they're not equal to each other, they're supplementary, right? And then the diagonals. Diagonals bisect each other. So here we have point M. Okay, yeah. So we have point M. So the diagonals, so P to M is the same distance from M to R, and then Q to M is the same distance as M to S. Okay, so the diagonals bisect each other. So let's look at a couple examples of these two. So we want to find M and N. So if we're looking at this, there's actually two ways we can go about it. We can use the fact that this angle, 2M and 70 are equal. Why don't we go ahead and do that? So 2M is equal to 70. Since they are opposite each other, they are congruent. And then you just need to solve that equation for M. So the 2's here cancel out. You get M is equal to 35. All right. So here, the angles 70 and N, those are not the same. And since they're in a parallelogram, if they're not equal to each other, they are supplementary. So I can solve N this way. 70 plus N is equal to 180. So, and solve for that. So subtract 70 from both sides. You get N is equal to 110. All right, and let's look at an example of the diagonals here. So remember, this point here splits both diagonals in half. So M is equal to 8. Those sides are the same. So M is equal to 8. That was super easy to find. K plus 4 is this part here. Is going to be equal to 11. K plus 4 is equal to 11. And then solve for that. Also an easy one to solve for. Subtract 4 from both sides. And you get K is equal to 7. And that will do it for the lesson today. I think more parallelograms next time. I'm honestly not entirely sure. But we'll see you next time.